On September 26, 2012, researchers at NASA's Johnson Space Center in Houston lifted the lid off the Osiris Rex mission's sample return canister. 2 days earlier, the mission had returned to Earth carrying an asteroid sample. Scientists were astounded to see a layer of black dust and debris on the canister's avionics deck when the lid was raised. In addition, the sample weight was 100 g higher than that of the Bennu collection. This was surprising because the sample had been kept secure in a sealed container the entire time. So how did this initially come to be? What could be causing the sudden black dust on the canister's avionics deck? And lastly, and perhaps most crucially, what are the scientists hoping to discover from the thorough examination of the biggest sample of recovered asteroids to date? The Osiris Rex mission had 3 main objectives when it was first launched on September 8, 2016. Sample collection came first, in order to provide essential material for scientists to research and comprehend the composition of primitive asteroids. The mission's goal was to gather pure samples from the asteroid's surface. Characterizing asteroids was the second. Bennu's geology was of interest to astronomers, and the mission's objectives included mapping the asteroid's surface, determining its composition, and assessing its potential as a resource for upcoming space missions. The assessment of the impact hazards on Earth constituted the third major goal. Bennu is a potentially dangerous asteroid, as was previously mentioned. Bennu will travel close to Earth on September 25, 2135. Bennu's trajectory will be altered by the gravity of our planet, making future trajectory calculations difficult. This is due to the fact that non-gravitational forces like the Yarkovsky effect have the ability to drive asteroids around in addition to gravity. An asteroid that is rotating experiences heat from sunlight striking its day side, which then cools and releases the heat. The asteroid receives a tiny thrust from this, which over time may cause it to reverse course. Although the Yarkovsky effect is difficult to simulate, it can have a significant impact on the final location of asteroids. We don't know exactly how the Yarkovsky effect will affect Bennu's orbit, so our knowledge of its location as it gets closer to Earth in 2135 is restricted. Because of this, scientists must take into account a variety of potential paths based on how hard Bennu is being pushed by the Yarkovsky effect. A small number of these paths coincide with areas of space known as gravitational keyholes. Earth's gravity would bend Bennu's route in such a way that it would impact an orbit after passing through a keyhole. Although the likelihood of this occurring in the late 22nd century is quite slim, scientists are nonetheless interested in learning as much as they can. The voyage to Bennu lasted for 2 years and 4 months. Osiris Rex reached its destination on December 3, 2018, having traveled a distance of roughly 2.2 billion kilometers, or 1.4 billion miles. It started a sequence of scans and mapping operations to determine the best location for sample collection as soon as it entered orbit around the asteroid. The sample collecting event on October 20, 2020 was the most exciting part of the Osiris Rex mission. The sample was taken by the spacecraft using its touch-and-go sample acquisition mechanism, TAGSAM, which made a fleeting surface contact. The robotic arm, known as TAGSAM, is affixed to the main body of the spacecraft and is responsible for gathering an asteroid sample and transferring it to the Earth return vehicle. Bennu is a tiny asteroid with a diameter of only 500 meters, so the arm had to gather the sample in an environment with very little gravity. There was just one shot available to Osiris Rex, and there was no room for error. Ultimately, surface material was stirred and lifted into the sample collection chamber using a blast of nitrogen gas when the spacecraft finally made contact with Bennu at a location known as Nightingale. Osiris Rex collected 300 g of the sample during the brief 9-second interaction with Bennu, exceeding the minimum required sample quantity of 60 G. That is 5 times more than NASA had projected. The sample was contained, but there was a problem. The substance was leaking out because of a jammed flap brought on by bigger rocks. NASA chose not to measure the sample as planned and instead sealed it for return in order to prevent additional loss. On May 10, 2021, Osiris Rex left Bennu and started its return trip to Earth. On September 24, 2023, after traveling for nearly 2.5 years, the spacecraft approached Earth's orbit and released the capsule holding the sample from the asteroid. At a speed of 12 km/s, the capsule descended into our planet's atmosphere, using its parachute to halt its entry. At the Utah Test and Training Range, the capsule touched down without incident, and NASA staff members retrieved it. A few days afterward, researchers at NASA's Johnson Space Center in Houston removed the cover from the Osiris Rex mission's sample return container. A sight that astonished and excited them was presented to them. The avionics deck of the sample canister, which most likely belonged to Bennu, had a covering of black powder and sand-sized particles on it when they first noticed it. The canister's exterior, including the avionics deck where the electronics were located, was likewise covered in dust in addition to the interior. There were microscopic gaps between the body and the cover of the canister that allowed dust to escape. It begs the question, how did this happen? NASA reports that Osiris Rex's brief collision with Bennu is thought to have created a shock wave that swept across the asteroid's surface and caused some elements to be ejected into space. A portion of this material adhered to the outside surfaces of Osiris Rex and followed it as it withdrew from Bennu. Furthermore, some of it mixed with the material collected by TAGSAM after entering the sample canister via the open flap. The sample's total mass, including the dust and debris, is about 400 G, which is more than what is needed to achieve their scientific objectives. Moreover, it is stated that the sample has not been exposed to excessive heat or pollution during the return trip, which has kept it in outstanding condition. One particular problem, though, is the avionics deck's accumulation of dust and dirt. The scientists must handle and clean it with great care, using certain instruments and methods. Their goal is to clear the deck of dust and dirt without damaging the electronics or losing any of the content. As essential parts of the sample inventory, every dust and debris fragment needs to be painstakingly recorded and catalogued. This mission to return samples is historic. But why are space organizations spending billions of dollars to travel to barely half a mile wide space rocks? The reason for this is that asteroids are like time capsules. They originated when the planets were still developing in the early solar system. Although they have not undergone plate tectonics or other geological processes, asteroids are composed of the same components as planets. Thus, they are able to conserve a record of the early solar system that is not present on our planet. For instance, researchers have discovered that asteroids are home to a variety of chemical substances. These chemicals are regarded to be the building blocks of life, and their presence on asteroids shows that the components for life were there in the early solar system. One particularly noteworthy instance is the finding of organic compounds on the asteroid Yugu. Yugu is an asteroid rich in organic material because it is a carbonaceous asteroid. After samples from Yugu were brought back to Earth in 2020 by the Japanese spacecraft Hayabusa 2, scientists examined the materials and discovered a range of organic substances, including amino acids. The building blocks of proteins, which are necessary for life, are amino acids. This raises the potential that in the early stages of life on Earth, asteroids may have brought essential elements to the planet. Osiris Apex, the new name for the Osiris Rex mission, will investigate asteroid Apus in its next phase. Apus is a near-Earth asteroid that has a diameter of around 340 meters or 1,100 feet. It is predicted to approach Earth closely in 2029 and to have a 1 in 150,000 chance of striking the planet in 2068. APOS will receive Osiris Apex in April 2029, a few months after APOS's near miss with Earth. The satellite will observe APOS from orbit for 18 months. Osiris Apex will utilize its tools to photograph and map the asteroid, analyze its composition, and determine its dimensions during this period. An important step toward better understanding near-Earth objects and the threat they represent to Earth is the Osiris Apex mission. The information gathered by the mission will help us defend Earth against asteroidal strikes.